Here is a Minecraft piglin in Minecraft. As you can see, he's made up of cells. In fact, all living things are made up of cells. Cells are very important in the body. They carry out various metabolic processes, produce energy in the form of ATP, and even divide to heal wounds. As you can see, this piglin has been through a lot. Let's take a look at how this piglin's cells will divide to heal his wounds. Hello and welcome to our stop motion video covering a cell's journey through life. From towering redwood trees to the tiniest microorganisms, all life on Earth starts with cells. But before we start, let's understand what a cell really is. Cells are the fundamental units of life, each filled with bustling activities, tirelessly working to sustain life. Cells are present in various shapes and sizes, but they all have a mission to grow, repair, and multiply. You may be wondering, how do these microscopic organisms ensure survival? Well, the simple answer is cell division. Let's have a brief overview of what happens in the cell cycle. What you're looking at right now is a cell's life cycle. It is split up into two main segments, interphase and mitosis. Interphase is where the cell prepares for division by growing and duplicating its DNA, but mitosis is the process where the cell splits into two identical daughter cells. The cell that we will be using for illustration will have 6 chromosomes, and it will be a diploid cell, which is what the 2N resembles. And during S phase or synthesis phase, they will duplicate and form 3 unique sets of chromosomes, which is represented by the notation 2N equals 6.
Yo dude, look at that.
Look at what?
Do you see that?
Oh shoot, what is that? Wait, why is it getting bigger? Watch out! The cell cycle begins in the longest phase, which is a whopping 18 to 20 hours long. Interphase is where the cell grows and performs its normal functions, preparing itself for division. Interphase is split up into 3 stages, G1 phase, S phase, and G2 phase. In G1 phase, the cell grows in size, producing the proteins and organelles needed for division. You can think of this phase as bulking. The cell is hitting the gym and getting big for division, because you can't divide in size if there's nothing to divide. Next, in S phase or synthesis phase, DNA replication occurs, and each chromosome in the nucleus is duplicated, resulting in 2 sister chromatids. These chromatids are linked like conjoined twins, held together by a structure called the centromere. You hear me saying the chromosome this, chromatid that, and you probably think I'm losing my mind. Let me clarify. A chromosome is made of chromatin, which is DNA wrapped around histone proteins. When the chromatin condenses, it forms visible chromosomes. During replication, each chromosome is made of 2 sister chromatids attached at the centromere. So after replication, what we see as a chromosome is actually 2 chromatids attached together. Lastly, in G2 phase, the cell continues to grow, like in G1 phase, but it produces more organelles and molecules required for division. The G in G1 and G2 means gap or growth, because these are the phases where the cell will grow.
Following interphase, we have mitosis, which includes 5 stages: prophase, metaphase, anaphase, and telophase. This creates the acronym PMAT. Starting in stage 1, prophase, the nuclear membrane starts to disintegrate and the nucleus disappears as the nucleolus breaks down. The chromatin condenses into packed chromosomes. Stage 2, metaphase. The chromosomes now begin to line up along the equatorial plane or the metaphase plate. The centrioles start to move toward opposite ends of the cell and spin out a system of microtubules known as spindle fibers, attaching to a part of the centromere called the kinetochore. Stage 3, anaphase. The sister chromatids of each chromosome separate at the centromere and move to the cell's opposite poles. The chromatids are pulled apart by the spindle fibers, which begin to shorten. Stage 4, telophase. The final phase of mitosis is telophase. A nuclear membrane forms around each set of chromosomes, creating 2 nucleoli. The nucleus then reappears as the nucleus reforms. It is now time to divide. The process where the cytoplasm splits is a process known as cytokinesis. The cell starts to split along a cleavage furrow, which looks like a groove at the cell's surface. The cleavage furrow then pinches apart the cell membrane, forming two distinct daughter cells, while the chromosomes decondense and spread back out into chromatin. Now we finished where we started. These daughter cells re-enter interphase and the process starts over again.
Throughout the cell cycle, checkpoints act as police stops, metaphorically halting the cell for checkups. These occur between transition phases in interphase and involve specific proteins and complexes that monitor the cell's environment. If any errors or abnormalities found during the checkpoints, cell cycle halts for repairs. If the damages are unfixable, apoptosis occurs and the cell will be programmed to death. Like all living things, cells get tired too. They always have the option to say bye to the cell cycle and enter a resting phase called G0 or G0 to take a break from division and just carry out specialized functions until they receive signals to re-enter the cell cycle. Many differentiated cells that don't need to divide, like nerve cells or cardiac muscle cells, can be found in G0, but this is only because they already have specific functions that they carry out within the cell. Voila! Now look at our handsome piglet. His wounds have been healed. Look at him live out his life to the fullest, contributing to society in a positive way. Or not.